In today's video, I'm going to teach you everything you need to know in order to use the Pathlib module in your day-to-day coding. From path manipulation and file system traversal, file reading and writing, we'll do it all. I'll even show you how to convert an old script to use Pathlib and some real-world examples from one of my work projects. My name is Jake, and this is the Python Standard Library. The Pathlib module was added in Python 3.4 and is my favorite way to work with files and directories. In fact, it's what I use in all of my personal projects and most of my work projects. And it's in one of those work projects that we're going to start our exploration of Pathlib. And that's because, as you can see, there's a mix of different file types and directories in this structure. And the directory isn't so overloaded that it'll be difficult for us to see exactly what's going on. So within here, we'll launch IPython and we'll import Pathlib. So most of the time that you're going to be using Pathlib is going to be through one of these main path classes. Today, we're mostly going to be dealing with this main path class because it exposes the maximum amount of functionality. However, if you need something more specific, we do have some alternatives. POSIX paths are for people on Unix-like systems. So that's either Unix itself, Linux, or Mac. The Windows path class is also available, but we don't see that here because this is just tab completion for classes that start with P. So we just see pure Windows path. But what is a pure path compared to this path class up here? Well, pure paths are mainly for just dealing with the paths themselves and are mainly geared towards tasks like path manipulation. So if you want to restrict an interface to not be able to really touch the operating system itself or interact with files, pure paths are likely the better way to go. But that's not what we want today. Today, we'll just be using this path class. And the way that we're going to get started here is we're going to create a new object, which is going to be an instance of this path object by using a class method called CWD, or current working directory. The reason why I'm going to rename it here is because PWD is the Linux equivalent of CWD, and that's what I'm used to using most of the time. And if we look at PWD, we see we have this POSIX path object, and it gives us the absolute path to the directory that we're in. Now, there are a couple different ways that you can create path objects. Another way would just be call pathlib.path, and you can either pass in a dot in a string here, which means the current directory, or you can leave it empty, and that gives you the same result. So if we look at cur now, we see same POSIX path object, except the directory is noted as a dot, meaning it's the current directory that we're in. Now there's some notable differences here between PWD and cur. The biggest difference being that PWD is an absolute directory and cur is a relative directory. Now where you can run into issues here is if we look at one of the attributes exposed from this object, parts, you can break down PWD into its directory parts. Starting at the / there, which is our root directory, then home, Jake, programming, and broker, the directory we're currently in. But if we were to try the same with cur, we see nothing. But there is a way around this, and that is with the absolute method. Here we can get the absolute directory from any valid relative directory. And if we recall parts on that, we get our absolute parts. So you can convert relative paths into absolute paths anytime you want, as long as the path is valid. One good way to check to see if the path is valid is with the exists method, which if you're accepting user input for paths, that's absolutely one of the first things you want to check is call.exists and see if it's actually there or not. There's also a number of other different is helpers that are exposed from this class. A few ones I want to call out here on the screen are is absolute. So you could do a check between absolute or relative. Is directory and is file are also great helper methods. Is relative to is an interesting one that you may have to use at some point, but there's also another way to check that, which we'll get into later. And then the final one I will call out here is the is symlink method. which can come in handy if symlinks is something that you commonly run into. To show you what this looks like, we'll call is_dir here. It says true. And if you change it to is_file, we see that pwd, which is the broker directory, is not a file. It is in fact a directory. Now the usefulness of path objects should already be evident, but we're just getting started. Not only can you check the directory that you're currently in, but you can also look at parent directories. And since this also returns a path object, you can go and check the parent of that, all the way up to the root directory, meaning the very base directory. For Windows users, you also have drive available, but that's not really something that makes sense in a Linux environment. So let's check one of those interesting properties by storing our parent as up, and I'll show you a little bit more magic right here. If you use the less than operator, we can check to see if a directory is a parent of another directory. The inverse can also be checked, and we see that up is not a child of pwd. It can be a little bit confusing to think of the relationship between these two using less than or greater than. So the way I like to remember it is that the path length of pwd should be greater than the path length of its parent. Now keep in mind that this isn't a path length comparison though, because if we check the relationship between another directory and pwd, this one having a significantly shorter path length, we see that it in fact is not a parent. So this isn't just pure path length comparison, it's actual parent relationship checking. Now, speaking of parent relationships, let's get into some interesting stuff here. So before, you'll notice that I listed out the contents of the current directory that we're in. And you can also do the same thing using these Pathlib objects. So we can get a list of children by running list pwd.iterdir or iter directory. The reason why I'm calling list here is that iterdir literally creates an iterable that you can iterate over, which is really helpful when we have directories that are large and you don't really want to list them all out at once. You just want to iterate over them and do something with that. Of course, I will need to store that to children. We run this and we see children is equal to a list of all the different files and directories that are under our current directory, including ones that were hidden because they're dot files. You can also get creative with this. So if you want to get all the child files from a particular directory, you can do a comprehension. So path for path in pwd.iterdir if path.isFile. So this gives us just a list of everything that's a file in this directory. And the inverse is true for directories. So we change that to is_dir and then create child dirs. Run that. We now have child dirs, and that's all the directories. This is really useful for doing recursive directory traversal. So if you're writing some program that needs to go through every file under some subdirectory, what you can do is use iterdir. If something's a file that matches whatever you're looking for, you can either register that or ignore it. If it's a directory, you can recursively do the same process with that directory. This is a surprisingly common pattern. Now, there's also a really nice way to do this if you're looking for particular types of files as well, or files with a particular pattern. So if we want to look for all YAML files in this directory, we'll run list pwd.glob. And globbing is effectively just searching this directory with this specific pattern. The asterisk there being a wildcard, which means we're going to match anything, any number of characters before .yaml. So if we run that and check the contents of YAML files, we see we have 4 YAML files in this directory that matched our result. Pretty nice, right? So these are all things that exist right now, right? But what if we wanted to work on something that might not exist yet? Well, let's create a new path. And for this, we're going to do pwd.joinPath. And what we're going to pass in are additional arguments. The first will be scripts, and the second will be testscript.py. Now, there could have been an arbitrary number of arguments that I passed in, And what's going on here is each of these arguments are going to be new parts in the new path that's created. So scripts is going to refer to a subdirectory named scripts, and testscript.py is going to refer to a file, testscript.py, under the scripts directory. So let's create that and see what it looks like. Now we have new path, and you see how it joined those together. That's pretty handy. But there's also a nicer looking way of putting these together, and it involves some syntactic sugar. And to do this, instead of passing arguments along like that, what we're going to do is use this notation right here. So pwd/scripts/testscript.py. So don't think of these as division. Think of these as literally just adding new dashes onto the end of pwd. And if we hit enter and look at new path, it's the same exact thing as before. The only difference being that depending on your preference, it might look a little bit better to create it this way. Though for those that are unfamiliar with Pathlib, they may be completely unaware of exactly what's going on here. But now you know. So let's look at some of the attributes now that our new path is pointing to a file instead of a directory. And again, we can check that by seeing is file. Oh, well, what's going on here? Why is it evaluating to false? Well, the answer to that is that isFile only works if a directory actually exists. And since this is something that we just made up, it currently doesn't exist. But even though a path doesn't exist, we can still do some interesting things with it. For example, we can check out its name, testscript.py. We can also check out its suffix, which is the file extension, as well as the stem, which is everything before the suffix. And if we really wanted to, we can even change those. So if we wanted to change that from a Python file to a shell file, we can say new path is equal to new path.withSuffix.sh. And now we have new path, which is testscript.sh. Of course, this doesn't currently exist, but we can remedy that. So first, let's see if our parent exists, and it doesn't. Well, Pathlib makes it really easy to also create directories. So even though that directory doesn't currently exist, you can call makedir on it, or make directory. We can have it be recursive, so that way if it's multiple directories that needs to be created, we pass parents is equal to true. Additionally, if this isn't a script, and you want to ignore any errors in case the parent directory already exists, a common thing to pass into this function is existOK is equal to true. Okay, so at this point, it should have created that new directory, and we see, yes, new path out parent does exist. And now that we have a parent directory for it to exist in order to create the file, all we have to do is touch it. All it simply does is if a file doesn't exist, it creates it. And if it does exist, it just updates the timestamp of when it was last modified without actually modifying the contents of the file itself. So it's a nice unobtrusive way to make sure that something is actually there. And finally, we can see if new path exists, which is now true, and we'll retry our isFile, and we see that, yep, new path is indeed a file. As you can see here, there's a lot of functionality that's built into these path objects. And even though we've already covered a lot of ground, there's still more to get to, so let's change gears a bit. And look at the example of an old script. This one is using the os module and the shutil module, which for a long time were the standards with dealing with files and directories in Python. The glob module was also really common when you wanted to do glob operations, but as you saw earlier, that's just built into path objects now, so we can altogether remove the glob import. Let's take a quick look through here and see exactly what's going on. Now this is all running relative to the directory wherever we run this script. First, it's going to create a new directory, then it's going to use the open context manager, directly passing in the mydir/myfile.text string. And then with that file handler, it's going to write to the file. It's going to do something similar with reading to the file, updating the contents, and then reading the contents again. Each time it has to pass in that string as a string itself, create the file handler, and then either read or write from the file. At the end here, it's calling os.remove, again, passing in that same string. And then to delete the directory that it created, we needed a whole other import, which is shutil here, just to remove the directory. Now, of course, this is still pretty clean looking code. It is Python, by the way, but we can definitely improve this with Pathlib. And for those curious, yes, it does execute, it says hello world and goodbye world, and shouldn't really leave any trace. There you go. MyDirt doesn't exist at the end of this, so it does clean up after itself correctly. Now, if we wanted to convert this to use Pathlib, what would that look like? So the first thing we're going to do is import the path class from Pathlib. And since we know that we can already reference the parent directory of any file that we're working with, what we'll do is create a myFile object, which will be an instance of path, passing in myfile.text, and to make the directory, say myfile.parent.makedir, and we're done. We can now remove os.makedir. If this was an absolute directory and we really wanted to make sure that all of the parents existed, remember we can pass in parents is equal to true, as well as exist_ok is equal to true. Now, for working with the file itself, Pathlib gives you two main options when you want to work with the contents of the files. Instead of using with open, we're going to say with myFile.open. Since we already know the name of the file, it's still going to be in write mode as f, being the file handler. And we delete this line here. So already a bit more succinct. And then we can call f.write hello world. But the second option, and this is the one that I like to use for more simple contents like this example here, is remove this whole thing here with the context manager, and we can instead write text. myFile.writeText hello world. Does it really get more simple than that? Not only can you write text, you can also write bytes if you wanted to write byte strings to a file. So both options are available with simple helper methods. Same thing with this next example. Instead of a two-line context manager to print the contents of a file, we can just print myFile.readText, and we're done. Once again, with writing, we'll just copy this here, paste it back in, myFile.writeText, nice and easy. And then for our last example, we'll read from it again, and we're done with the core part of our script right there. These write text and read text functions are really helpful. You can definitely shorten up the contents of scripts you may be writing. Now finally, to delete the file, instead of calling os.remove, we'll just call myFile.unlink. Unlink effectively being a delete. And the very last line here, instead of having to have an shutil import to remove that directory, we just call myFile.parent.rmdir, or remove directory. Beautiful. And finally, we can get rid of these two unnecessary imports and just have our single Pathlib import. So not including import statements, blank lines, or comments, all of this is just 8 lines of actual code. So you can really see the beauty of Pathlib. Now we'll save this as new script and run it. We see we have the same output as before, and we shouldn't be able to move into the directory because again, it cleans up after itself. Awesome, so our conversion is done. But before we go, like I said at the beginning of the video, I want to show you some interesting examples of using Pathlib from code in one of my projects at work. The first being from this helpers.py file. In here, we have a helper function called loadFile. So this takes in some type of file. And at the very top of this function, we have what is, in my opinion, a bit of a best practice when you're not sure exactly what's being passed in. It's just to explicitly call file is equal to path file. That gives the users of this function the ability to either pass in a path object or a path string. So we just handle it with an explicit conversion and we don't need to worry about it. Now, next we're going to combine a few checks here. So the first one being if the file doesn't exist or if the suffix isn't one of these 3 suffixes that we would accept in this function, then we're definitely not going to try to load the file itself. We can either warn the user that what they did wasn't correct. Notice the use of file.absolute here. That way, in case they pass a relative directory and may have been mistaken about where they were running this from, the absolute directory being resolved would make it quite clear where Python was expecting the file to be. Or in other cases, we could just return an empty list. The rest of the function is pretty standard. It's basically just loading this either through JSON or YAML loaders. Now moving on to a settings file, one really nice helper function I like for settings is the home method. So this evaluates to a user's home directory, whether that be in a Unix style system or a Windows style system. This is a common place to put things like configuration files or other common files to your project. And that's what I do as the default for this project, is I take the user's home directory and then I add on a .broker subdirectory. This could be overridden with an environment variable. I check to make sure that the location passed in by the environment variable is a valid directory. If so, then we go with it. And of course, we want to make sure that the directory exists that we're working on. Passing in parents is equal to true and exist OK is equal to true. And then we create two new paths pointing to files that either should exist or will be made in the execution of this program. The most important right away being the settings file. So we check to make sure that the settings exist. If not, we warn the users and then do a little bit of settings initialization that we won't cover today. The next example is a little bit devious. So what I'm doing is combining a little bit of magic here. And this is very situational to this project, but maybe something that you could use in another project if it comes up to it. So basically what I'm trying to do is determine the names of imports for Python modules, or what we call them in this project being providers, at runtime. This way we can dynamically load any number of providers that have been defined by either some other contributor, allowing for a flexible plugin system. And the way that we're doing this is we're going to iterate through all of the Python files that are in the parent directory relative to this file itself. So what does that mean? Well, if we look at this directory on the left here, we see that we are under init.py, and we have Ansible tower.py, beaker.py, container.py, and testprovider.py, all in the same directory. These are all what are known as providers for this project and are effectively plugins. So what we're trying to do is find the name of each of these: Ansible tower, beaker, container, and test provider, which would then be import names for the project itself. And the way that we're checking this, by checking, again, all Python files in this directory if the stem isn't dunder init. So everything except for this dunder init file. Again, this is very situational, but shows the combination of a few different helper methods that Pathlib exposes all in a single line here, albeit a fairly lengthy line. And then the final example that I want to give is this PyTest fixture here, which simply creates a backup of an existing file by calling a rename on the file and renaming it to its current name .back. So create a .back version of the file. And then after the tests have executed, we then destroy the newly created file and then restore the backed up file to its previous path. And that wraps up this video and our first stop on the Python Standard Library tour. If you learned something new, please consider subscribing to the channel and sharing this video with your friends. If you have any questions or comments, please leave them in the comment section below. And as always, thanks for watching.